My name is Annalisa Pawlosky. I'm a senior staff research scientist at Google. I've been there about 10 years, and I'm here today because we have a project on ALS, and we're looking to see if we can help solve ALS with some of our agentic model systems. Google Co-Scientist it's kind of this very powerful engine that we built, and it canvasses the literature and tries to make unique connections across the literature to find unique mechanisms and then provide reasoning and evidence for those mechanisms. And we back it up based on web search, and we do lots of reviews and other things. And so the idea is a novel hypothesis generator. And so we're using it to study complex diseases like ALS. And so we build it, so it's a powerful engine, but we want to build the whole car. So that requires the data analysis, and Target's been great because you have a great consortium of data that we've been able to leverage. Having the engine to come up with novel ideas to understand those connections and either support or kind of remove some of the hypothesis from the data, and then actually to test the ideas in a lab. So we try to do all of those things. Before, you would have to read through all of these papers, and then over decades worth of reading papers, going to conferences, talking to people, you would start to build out these connections. And here with Co-Scientists, we run it for several days, and so you can ask a lot of different questions. Why do ASOs that target TDP43 do not work, right? What are all the reasons why, the mechanisms why? Or what's a novel mechanism that explains the iron dysfunction that we see in ALS, something like that. And so in those, it produces hundreds to thousands of ideas and then competes and ranks these ideas. And then scientists can review them and say, this is like something I didn't think about before, something that helps me move in a different direction. And so we're trying to compress that time, but you want to move forward with quality. So you can move fast, but you want to move fast in the right direction. And that's kind of why Co-Scientist requires expert review, data analysis, and then testing the ideas. Having these, especially like the post-mortem tissue data sets, the spatial transcriptomic data sets, they're so powerful and valuable in the amount of signal that you can get out of them. So, I know all of that work took a lot of years of planning to put it together, but now that AI has gotten to a place where, people are using it to do data science, people are using it to come up with novel ideas, people are using it to try to put together the protocols for their different experimentation, we're able to kind of combine those two and weave them together and move even faster than we were before. So, we really feel that there is this incredible momentum and that potentially something really powerful can come out of doing this work together. When we run experiments, 80% fail, right? And when you do drug trials, there's also so much failure there too, right? And so you have to really motivate yourself to keep going. And I get that feeling from everyone around. It's like people are so motivated to figure this out, and it takes a lot of drive, and they're willing to make collaborations and try different tools and, keep pushing themselves. I just don't feel that there's this big ego here. It's really about how do we solve the disease to help the patients, and it's truly inspiring. I'm Annalisa, I'm from Google, and I'm building a world where everyone lives.